Hello, good day everyone. Welcome again to another edition of our Azure series of webinars. I'm your host, Terence Hermida. I'm the Cloud and Enterprise Lead, Business Lead for Microsoft Philippines. And today's topic is all about Azure Data Services. So what I intend to do for today is to give you an overview of the different Azure Data Services. Not all of them because it is a pretty big topic. So we will only tackle probably about half of them, and then we'll have specific and dedicated webinars on the other topics. Okay, so if this is your first time attending this webinar, please note that this entire webinar is actually recorded. You will get a email with the URL to the recording so that you can listen to this webinar at any time, at any date that you would like. You just require an internet connection and also a device that's connected to said internet connection to listen to this webinar along with the slides. Unfortunately, due to confidentiality reasons, a lot of people ask me whether I can send them the slides. Unfortunately, I cannot do that. So therefore, this is the recording of this webinar. When you get it, it's the only way that you can recall some of the contents of the slides. So that email will arrive to you in about 24 to 48 hours time. So don't worry about if you missed some parts or all of this or most of this webinar if you arrive late. So you can always listen to the recording. You can also ask any questions or questions in the chat in the question chat window. Post your questions there, and I will try to answer those questions during the course of this webinar. If I'm unable to do so, or if you run out of time, you can of course send me an email at hrmedia@microsoft.com. All right, so let's get things started. Now, we have Azure Data Services, which is a collection of services in Azure that is data related. There's a number of them that I wanted to show in this different slides. So the first set of Azure Data Services is what you see here, and we classify them as databases. So we have SQL Server running on virtual machines, Azure Cosmos DB, SQL Server Stretch Database, different Azure Database Managed Services for different types of open source databases, and what have you. There's also another set of Azure data services called the analytics services. So there's a whole lot of them. So that includes SQL Data Warehouse, things like Data Factory, Data Catalog, Azure Stream Analytics, Data Lake Analytics, and so on. So the coverage of this webinar, since we only have an hour, is we're going to see an overview and some level of detail as far as the database and the analytics services, which form part of the Azure Data Services that is available currently as of today. There are other data services such as AI and machine learning services. So as you can see from this slide, there's a whole bunch of them. So I've decided to have a separate webinar just to cover all of these AI and machine learning services and give you some usage scenarios. So we won't be covering all of this today. We also won't be covering IoT services. So as you can see here from this slide, there's a bunch of IoT related services where you can actually build IoT related solutions, such as using IoT Hub and IoT Central, or put together different components, such as using the Azure Machine Learning Service and Stream Analytics. So for the ML service and the Stream Analytics, we'll be taking a look at that as well in this webinar. But in the context of IoT, we'll have a separate and distinct webinar just for that. The same with blockchain services as well. It is considered as part of the data services, but we won't be covering that as today. So we'll just be covering data services and analytics. So the previous slides were kind of boring slides because it's kind of listed down all the different data services, but here's the Azure data landscape, and you see different icons that show you how these different databases are grouped together in terms of different types of storage, in terms of different managed data services, the different ways of which we prepare or model data for advanced analytic scenarios, data warehouses, and so on. Now, what do you want to, that all boils down to what is called the modern data estate. So the modern data estate is composed of on-premises databases and also cloud data services. So you use these data services in different scenarios. It can be on-premise databases or cloud service databases. It can be operational databases. It can be used as data warehouses. It can be used as data lakes. The whole point here is that you can split and you can split your data between on-premise and on cloud and have consistent platforms across, whether it's private cloud running in your own private cloud in your own data center or using Azure Cloud Database. So you can reason over your data anytime and anywhere because AI is built in. Right now, for example, you can use R and Python scripts to run machine learning algorithms on directly on top of the database. You can certainly do that with SQL Server 2019. You have flexibility of choice in terms of running it on any language, any platform, anywhere. And on the cloud itself, you're secure because our cloud service has holds more certifications than any other cloud provider. So that's why there's a lot of customers today. They have scenarios where they have data that's resident on the cloud, either as an operational database or data warehouse or data lakes. In certain scenarios where, for example, they would like the data to live closely to the, say, for example, advanced analytics components that are running on the cloud. On-premises data, for example, like we have a few customers like in the financial sector where they have data that's resident in their on-premise databases, say, for example, in SQL Server 2019, and they would like to keep it there because of they have their own reasons why they want to put it there. And they want those data to live with the or close to the core banking application. So those are just some of the scenarios. The whole point is that this is what the data estate looks like. And if we map that in context with the different services that we have on Azure Data Services, these are just some examples. So for operational databases on the cloud, we have the Azure SQL Database for relational data, Azure Cosmos DB for non-relational or NoSQL data, and for open source databases, we also have managed databases for MySQL, Postgre, and MariaDB. We also have a fully managed SQL data warehouse in the form of Azure SQL Data Warehouse. And for unstructured data that you would like to keep in a data lake, we have Azure Data Lake. As we've also adopted our own version of Azure Databricks for big data analytics and for the data analytics and AI solutions, and also HD Insights for open source analytics. So you actually have a flexibility of your choice, whether it really depends on the type of data that you would like to store, whether you need operational data warehouse, or data lakes and analytics. Now let's start with Azure SQL Database. This is one of our most common Azure data services, which are most common across all of our cloud customers or our Azure customers. Basically, all it boils down to is that Azure SQL Database is SQL Server managed at scale. So you can just imagine thousands upon thousands of instances of SQL Server being managed by Microsoft as a managed service. So some people call it like a database as a service. It's seamless and compatible with SQL Server, with various versions of SQL Server. It can be as back compatible to SQL Server 2008. So that certainly opens up a lot of scenarios wherein you can get out of end of support of SQL Server 2008 by using the managed Azure SQL Database. We'll talk more about that later. It gives you competitive TCO, not only because it is a managed database wherein you don't have to pay for capital expense for the hardware, as for also for the licenses, but also because it's running on the cloud, you don't have to manage and keep maintenance on all of that. But you also gets additional savings on something called the Azure Hybrid benefit and also reserve capacity. We can talk more about that later as well. Now, because it is a SQL database that is run at scale, you can achieve up to 100 terabytes of on-demand scale of storage per database. And this is per database. So you can have multiple databases of several thousands of gigabytes up to hundreds of terabytes on Azure SQL Database. It has industry-leading security. It also is backed up by a 99.99% availability SLA because, again, it is a managed service. And finally, it has built-in intelligence because the service itself is automatically tuned and performance tuned, and also provides protection against the usual and also zero-day attacks, zero-day security incidents that would come up in the future. There is a version of the Azure SQL Database called the Azure SQL Database Managed Instance. So this is essentially This is essentially as close to the native SQL Server that you all know and well. Again, it's backward compatible from SQL Server 2008 to SQL Server 2019. So which means that using any database migration service that supports the Azure SQL Database, you can actually migrate from SQL Server 2008 to Azure SQL Database Managed Instance with little to no changes in the underlying code as well. So it's a full SQL service area. We have native VNet integration, and because it's a managed service, it's always up to date. It has built-in high availability and always on. One of the things that people like about SQL Server, the reason why why customers acquire SQL Server Enterprise Edition is because of the availability of something called always on. So this is now a standard feature, and think about it as the world's largest always on implementation of SQL Server, and that Microsoft manages that across Azure. And like I said, it's 99.99% SLA out of the box. It has built-in intelligent performance and security. It's self-tuning and it's self-healing. You can now also hyperscale your database. So we now have a new highly scalable service tier that adapts to your workloads, needs auto scaling up to 100 terabytes per database. So if you turn on auto scale, you can actually provision one or more additional compute nodes that can serve as your read-only workload and use them as a hot standby in case of failover. So it opens up a lot of scenarios wherein you can have multiple nodes that can serve as your read-only workload, but at the same time, you can turn on auto scaling so that you can have your database auto scale to up to 100 terabytes, and you don't have to worry about sizing the database itself. So the only thing that you'd have to worry about a bit is the cost of running this hyperscale database. So you're going to have to watch out for your cost. But we have tools within Azure like Azure Cost Management that allows you to monitor that and gets alerts whenever your cost goes up to a certain limit. So a few customers have signed up for this one, and I'd like to point out a few of them right now. So DocuSign, if you're familiar with a company called DocuSign, they offer a solution wherein you can turn any paper document into an electronic document, and at the same time use this paper document to the DocuSign system, get a scan copy, and then you can then use your touchscreen finger or your stylus to sign on the electronic copy. So therefore, that becomes your electronic signature. So DocuSign is a global leader in e-signature and digital transaction management. They currently serve more than 300,000 customers and 200 million users on 188 countries. And behind their DocuSign system, which can be deployed across multiple types of devices and multiple types of applications embedded, is behind that is actually SQL Server. They were able to lift and shift the SQL Server code that was running partially in their database and in another cloud to the managed instance with no changes and start running the queries in seconds. So this is a quote from their chief architect where they are saying kudos about a SQL Server managed instance lifting and shifting from their current workload that was on premise. ASOS is also one of our top customers. So it's a top online fashion retailer. So if you go to ASOS.com, they're actually based in the United Kingdom. Their entire website or entire e-commerce capability is completely based on Azure, and behind that is the Azure SQL database that runs all of that. So just to give you an idea on the scale of which they operate, they are used by 13 million customers worldwide. And this new platform, meaning SQL Server running on SQL Server running on Azure as the managed service, this new platform was able to handle more than double the volume of Black Friday orders over the previous. So Azure is also the most effective cloud for your SQL Server. So we can prove to you, and you can go to the Azure website to show you an actual computation and a real computation as to how running SQL Server on Azure is actually more cost effective than any other cloud that you see out there, especially if you have active software assurance. You get a benefit that's called Azure Hybrid Benefit, which allows you to get discounts on running SQL Server on the cloud, whether it's a SQL Server on a VM or virtual machine, or SQL Server, or running your data, or you're getting your data hosted on Azure SQL Data instance. Okay, now one capability also of Azure SQL Server is stretch SQL into the Azure. So essentially, what this is that you have your SQL Server database, and we've started this capability in SQL Server 2016, and we've carried it over to SQL Server 2017, and now to SQL Server 2019. And it's going to be a mainstay feature on all versions of SQL Server moving forward. Essentially, what it does is that it stretches your large operational databases that are running on SQL Server on-premise to the cloud, to Azure, with the ability to query. So one practical use of this is that you don't have to worry about the limited size of your database that you may have on your SQL database on-premise, because it's going to automatically stretch your database storage-wise into Azure. So that also happens transparently behind the application. So when you're using the application on its in normal operations, and if the application triggers a query, that query will actually return rows both on the on-premise SQL Server database, and also the rows that may be in Azure, because you configure the stretch on SQL Server. So you actually configure the stretch capability on SQL Server on-premise, and then stretch that all the way to Azure. So it doesn't require any application changes. It's a cost-effective online cold data solution that is built in to SQL Server. So how it works is that it creates a secure linked server definition on the on-premises SQL Server. Of course, you will need an Azure subscription for this to work. The target will remote endpoint with link server definitions, and then from there, it provisions remote resources and begins to migrate eligible data. So you don't even have to tag what data is eligible to be stretched to Azure. It's up to the algorithm that's built in to do that. So this is usually archived data, like for example, data or rows that is not normally queried, that are put into Azure, and it's smart enough to figure out that if certain rows and certain data is being queried more frequently than usual, then it brings it back to the on-premise database. Now, switching gears over to open source, we now have Azure Managed Database Services for MySQL, PostgreSQL, and MariaDB. So what we did is that we took the managed community versions, the latest ones, and we consistently and constantly update these managed community versions, and made it as a scalable managed service across Azure with built-in high availability. So this addresses some of the common problems of application developers or full stack developers that would like to use open source databases. One is that it's quite a pain. It's also quite difficult to configure MySQL, Postgre, and MariaDB on a high availability, and also in a security and compliant fashion, because these are not commercial databases, so they don't actually you'd actually have to configure the security, compliance, and high availability once you've downloaded this, and you have to do it yourself. So what Microsoft essentially did is that we made it enterprise ready, put it across, now almost all of our Azure data center regions. I think right now it's in about 40 to 50, about out of the 54 Azure data center regions, and make it industry leading and global reach. So like I said, this is a managed community version. So we constantly update these managed community versions. We take care of the automatic updates. We fix the security fixes, or we put in the security fixes. We put in new feature updates. Currently, we are at MySQL version 8.0. Postgre is on version 10, and MariaDB is in version 10.2. So rest assured that if there are any newer versions outside of that, Microsoft will take care of upgrading our managed clusters all across our Azure data center ecosystem, data region ecosystem, so that you can get the latest versions of these databases. You can also scale in seconds with built-in high availability. So one of the things that we have put in here, and we have considered, and we've listened to our customers, is that you would like MySQL, Postgre, and MariaDB to be scalable, and not only scalable but be scalable on demand. We also slapped on a high availability SLA. The current SLA is 99.99%. As with any other SLA of Azure, all of these are financially backed, meaning if we do not meet the SLA uptime requirements, you will actually be paid you will actually be paid as part of the service. So it stays up and running without the need of additional replicas, and so therefore, you can rely on an easy and cost-effective disaster recovery with a single click because it is actually already built in. It is secure and compliant. So like I said, first of all, because they are running on Azure, that in itself complies with over 200 different security compliance standards all over the world. You can also be ensured that your data is protected with up-to-date security and compliance features using the Azure IP Advantage. You can also it's also securely built in with native and Azure Active Directory integration. So in the open source version that you would do on-prem, you'd have to configure this yourself. But in the managed database versions in Azure, that integration is already native. You can also control access with secure SSL, server firewall, secure rules, and VNet, which is quite difficult to do if you want to do it on-prem. You have to configure these yourself, like I said. Encryption is also built in for data and backups for both in motion and at rest. So this addresses the requirements of most of our customers who would want to run and still remain on open source databases, but would like to encrypt their data. It also provides, because it runs now, I think, across more than 40 Azure regions worldwide out of the 44. We now can actually provide these open source databases at scale within practically global reach. And all of these managed services are now running on Generation 5 hardware, so therefore it runs on the latest hardware and more secure hardware, in fact. And we target that this will be in all Azure regions before the end of calendar year 2019. It is also integrated with the Azure ecosystem. So imagine a scenario where you have, for example, a website, for example, that's running on the Azure App Service. The app service natively can connect to a MySQL instance that's running on the Azure MySQL database service. So that's an example of what we mean by easy integration into Azure services. You can get your app up and running with built-in connection to app services and other app services. You can then take advantage of using other services such as AI services. The whole point is that because it is within the Azure ecosystem, you can then take advantage of getting your data to live within the native open source database of your choice, whether it's MySQL, Maria, or Postgre. We are not forcing you to move from MySQL on-prem to SQL Server on-premise on the cloud, for example, but still keep it on MySQL, but still continue to work with and integrate with other different servers. So one of our biggest customers on, I believe it's there you go, my Azure SQL Database. MySQL database is GeekWire. So they moved their WordPress site to Azure Database for MySQL, which allowed them to increase or to decrease their load their page times. They now have on-demand scalability, especially if, for example, if WordPress experiences surges of users, which sometimes happens, and also a 45% reduction of cost. That's quite significant for essentially a tech company like WordPress. Now, I'm going to move over to something called Azure Cosmos DB. So Azure Cosmos DB is our fully managed, globally distributed NoSQL database service with guaranteed low latency and massive scale. So this is quite similar in use to MongoDB, which is probably one of the more popular NoSQL databases on premise. So we took that notion and we built something called Azure Cosmos DB. It's a NoSQL database that is fully compatible with APIs such as Stable APIs, Cassandra, SQL, MongoDB, and even Gremlin. So you can now migrate your NoSQL data to Cosmos DB across a distributed and fully managed NoSQL database, so which means that it also has a 99.99% SLA. The one thing that's kind of unique with Cosmos DB is that we don't only just have an SLA on the uptime, but we also have an SLA on the response time, on the query times as well. That's how confident we are with Azure Cosmos DB. You now have enterprise grade performance for your NoSQL data. So because now you can experience low latency at any scale anywhere in the world. It's also quite developer friendly because any developer, for example, that have created a web application or an e-commerce application that uses MongoDB as a background, they don't need to make any changes in the code because Azure Cosmos DB understands the MongoDB API. In fact, you can just point your application to Azure Cosmos DB using the native MongoDB API, and then it'll still continue to work. So we also guarantee the high performance anywhere in the world. So this is what I was referring to a while ago. We have a financially backed SLA for a millisecond latency at 99th percentile, 99.999% HA. So it's one of our highest availability SLAs that's across all of our different services. Cosmos DB, we guarantee 5 nines. Throughput is guaranteed and also consistency is guaranteed. You can also migrate NoSQL apps to Azure Cosmos DB quite easily. So you can make data modernization easy with seamless migration of NoSQL workloads to the cloud. So you may have, for example, an on-premise NoSQL database running on Cassandra, MongoDB, Dynamo, Couchbase, or anything. And using the NoSQL Wire protocol, you can actually migrate all of that to Azure Cosmos DB. You can leverage existing tools, drivers, libraries, and existing apps. One of our biggest customers that actually uses Cosmos DB in the background and powers their entire e-commerce site is Domino's Pizza. So here's an example of how it looks like. So when you use a browser to order pizza on any Domino's Pizza website, the Azure Traffic Manager routes the order or the transaction to the Azure App Service, and behind that, which runs across multiple Azure regions, and behind that, you have Azure Cosmos DB. So what they have experienced is millisecond load latency and globally distributed order processing. So NoSQL is very popular and quite popular, and it turned out to be a very good alternative to traditional relational databases because because quite some time ago developers have figured out that relational databases can be quite slow if you're just going to use it for e-commerce traffic. So therefore NoSQL becomes a better alternative. When Citrix wanted to create a single sign-on system for 10 million users, they turned to Cosmos DB to take on the challenge of customers encountering multiple sign-in prompts between disjointed Citrix websites. So the services that actually power Citrix's cloud services, the authentication service of those services is actually powered by Cosmos DB on the background. It provided significant impact in terms of the performance of the application because they now have streamlined access to greater than 49% availability and enterprise-grade SLAs, and they have now improved access to more than 10 million users. And they have reported login times to be faster, and login kickouts or users being kicked out of their logins becoming less and less and almost eliminated. Now, there's also another company called Jet.com. So Jet.com is also a very popular e-commerce site, one of the bigger competitors of Amazon.com. So one of the things that they wanted to do in terms of transforming their retail presence online was to deliver the most competitive pricing to customers with real-time price comparisons. And the way they already created the algorithm for that, but the one way that they could probably amp that further is to use a very fast NoSQL database in the background to process 100 trillion transactions a day across multiple regions using single-digit latency, and they were able to achieve that using Azure Cosmos DB. Now let's move to migration. So now at this point we are in the halfway point of the webinar. So we've already discussed, for example, we have already discussed an overview of Azure SQL Database, the Azure open source managed databases for MySQL, Postgre, and MariaDB, and we've also discussed Azure Cosmos DB. At this point, how do we then migrate from on-premise to the cloud? So we can migrate SQL Server to Azure SQL databases for the best TCO. And so the best TCO, you avoid CapEx. You also take advantage of higher latency for SQL and always on SQL configured with all the latest and greatest security and version features are there. You can also migrate open source databases fully using MySQL and Postgre services in Azure. And you can also migrate NoSQL databases to Cosmos DB for guaranteed low latency. Primary tool that we use for that is a first-party tool called Azure Database Migration Service. It is a built-in native service within Azure that's accessible in the Azure portal that allows you to migrate with near zero downtime. You can actually run the database live on-premise while you are migrating the data. So it takes care of all of those row level locks to make sure that the data is being migrated in real time while you're actually using the database. So you don't need to put in, or you can actually super minimize the downtime. You can also migrate at scale. You can migrate from multiple sources to multiple target databases, and you can now free up time and resources that can go towards transforming your business. A few screenshots here on how Azure Database Migration Service works. So like I said, it is accessible through the Azure portal. Once you've already accessed that, you connect to the source, enter your server name, what type of authentication. This is an example, by the way, of migrating data from SQL Server on-premise database to Azure SQL Database Managed Instance. So enter your username and your SA password, encrypt the connection. Connect your target. So by selecting the name of your target, or putting the name, for example, putting the name of your activity first, and then or your project, and then put in the target server name. So as you can see here in this example, it is actually a SQL Server Managed Database. The FQDN of that database is here. And then you have one database to migrate. You can even select what type of validation options do you want after the migration, just to make sure that things are actually checked out properly. You can compare schemas, you can compare data consistency, and you can also do some test queries for query correctness. And then after that, you can sit back, relax, and watch the migration happening from on-premise to your data. Of course, before all of this happens, you need to make sure that you have the proper connectivity between your data center, the on-premise databases in your data center, to your Azure subscription. So that's how it works. Now, one thing that I'd like to point out for a few minutes is that SQL Server 2008 and SQL Server 2008 R2 has already ended support in last July 9 in 2009. So we're well into the time wherein if you are still running applications on SQL Server 2008, you will no longer get any security updates. It will open up your company into compliance and concerns and also risks, and also consider it as a missed innovation opportunity. So the main reason why you would want to get out of SQL Server 2008 and R2 on-premise is because there are no security updates. So what are your alternatives? So if you are using SQL Server 2008, you can move up to the cloud. So you can do SQL to SQL migration via Azure SQL Database, or if you're Azure SQL Database, or you can move what it's not shown here in the slide, but you can actually move the database on a SQL Server on a virtual machine as well. But like I said a while ago, it is also important to understand that Azure SQL Database is actually a good alternative because it has lower TCO compared to running SQL Server on a virtual machine, wherein you still have to pay for the license and do the configuration yourself. If you're running MySQL, you can move it to Azure Database MySQL Postgre MariaDB. If you're running on Oracle or an old version of Oracle which is no longer unsupported, you can definitely move that to Azure SQL Database. The Azure Database Migration Service does support that scenario. The Azure Cosmos DB. So if you are using, say for example, MongoDB on-prem, and then you want to migrate that to Azure Cosmos DB, you can do that. If you want to remain on-premise, you can modernize the SQL Server 2017 or SQL Server 2019 once it comes out. You can run this on Linux or Windows Server. We've started supporting Linux since SQL Server 2016. But the worst thing that you can do is do nothing, because when you do nothing, it means that when you leave your current applications on SQL Server 2008, in order for you to get additional support from Microsoft, you have to pay for what is called extended support, which is about 70 to 75% the cost of a new license. Admittedly, some customers decide to do that because they're not ready to move to the newest version, or neither are they ready to move to the cloud. But at this point, you now know the choices, so we can talk further later on which choices you want. All right, now let's talk about a little bit about the big data landscape. So remember this slide a while ago where I showed you the different data services that are database and analytics related. These are all the different types of components that are typically associated with Azure, with implementing Azure Data Warehouses or Big Data on Azure. So let's start with Azure SQL Data Warehouse. So for those of you who are attending this, who have been working SQL Server for quite some time, you know that one of the native capabilities of SQL Server is to be configured to run as a SQL data warehouse. Hence, we took that capability and we made it as a managed service on Azure, and we called it Azure SQL Data Warehouse. Um, so that's a managed service that we provide. So the Azure Data Warehouse enables transformative insights. It provides you with near real-time analytics. It also allows you to use tools that you already love, like for example, the back-end data services connectivity that's provided for by Excel, Power BI, and even third parties like Tableau and Click and more, and around 20 others. It already supports natively querying from Azure SQL Data Warehouse directly. You can also scale in minutes with more freedom. So I'll talk more about that later on. You can because it's a data warehouse, you can actually configure it to scale up to an amount that you probably have actually haven't considered yet in the past. Anyway, you also have this innovative pause feature to stop compute and even save more. The SQL data warehouse also has multiple layer protection. It has encryption at rest. It also has tools for you to monitor your data and your security, and it provides user access with Azure Active Directory natively. So one of the capabilities of Azure SQL data warehouses that our customer loves is that you can scale compute on the fly when you need it through units called data warehouse units or DWUs. So one of our customers, for example, a customer called Pound Sand, is one of the great features. Is one of the things that they wanted was the ability to keep up with the increased workload. So this particular customer, for example, is constantly collecting data across multiple applications and across multiple services and collecting it on Azure SQL Data Warehouse. So you can actually create a scalable data warehouse. You can start from 100 DWUs, or there's literally a slider in the Azure portal where you can select how many DWUs or data warehouse units do you want your Azure data warehouse to scale up to. So I don't have time to discuss what DWUs are, but you can look at the documentation what that actually means, but it's essentially a formula that combines both storage and throughput on the data warehouse. Now, you can also pause it if you want. So as you know, as everything in Azure, as long as it is live and as long as you're using it, you are actually being charged for that usage. So there may be instances where you actually don't need the data warehouse. You can pause it. You can you so do you so you don't need to over provision or overpay. So if let's say you got to a point where your database or your SQL or your data warehouse can't cannot connect or do not want to collect more data for whatever reason, you can definitely pause that so you don't incur any charges. So one of the workhorse services in Azure is also something called the Azure Data Factory. It is a fully managed data integration service in the cloud. It does data integration, data orchestration, also data movement with security and compliance underpinning it. So Data Factory is a service across Azure. So it allows you to modernize your data warehouse with Azure Big Data and advanced analytics such as HD Insights and Data Lake Insights. So it's a custom-driven um, application that's unique to your customer data using the language of your choice. A lot of our customers actually have migrated their SQL Server Integration Service or SSIS programs and scripts to Azure Data Factory. So Data Factory also allows you to bring together all your sources of data to understand your customers and drive impactful business decisions. So the way it fits within the whole architecture of data warehousing and advanced analytics is that Data Factory is the one actually doing the actual collections of data or ingesting data across multiple sources and then storing it in Azure Data Warehouse. So like I said, it is also a data orchestration service. It orchestrates your data pipeline from wherever your data lives, wherever it's in the cloud or in a self-hosted environment. It has truly hybrid integration capabilities because you can actually execute your SSIS packages in the cloud. So you may have SSIS packages that you're already running on SQL Server Data Warehouse on premise, and you can just migrate this on Azure Data Factory to continue to get data from the different internal sources, which may remain on-prem to be collected up to Azure SQL Data Warehouse. Data movement as a service. So it also accelerates integration and manage data movement as a service. You can provide your own. You can also you can do elastic data movement at scale. So we have, for example, examples where customers are actually integrating or getting data from more than 30 different sources. For example, I have one customer that actually does that across the cloud and then stores it in a single Azure SQL data warehouse. And they started that scenario by using SSIS on-premise first, and then they moved to Azure Data Factory after they made the decision to move their data warehouse from on-premise SQL to Azure SQL Data Warehouse as well. So essentially, Azure Data Factory allows you to do hybrid data integration at scale. So you can get data from any relational data, whether it's on-premise or from on the cloud. You can get data from non-relational data from either web, media, social media, or different devices like IoT data. And then you can then process the data, and then you can process the data on Azure using Azure Data Factory using multiple types of programs and scripts. Then it can be stored. Then store it in the Azure SQL databases, Azure SQL Data Warehouse, sorry, so that you can then serve it across any BI tool, run advanced analytics across it. And so Data Factory essentially orchestrates the data pipeline activity, workflow, and scaling. Which brings us to some common modern data warehousing patterns. I just want to get a quick overview of this because we will definitely have a future scheduled dedicated session and webinar just on modern data warehousing. All right, so for the load and ingest side, okay, so for the load and ingest side, the canonical operations work from left to right. So you first transfer and store the data, so that's called loading and ingesting. And then we process and clean the data, that's called process. And then we serve and analyze the data across multiple publish points. So it may be Power BI, it may be Excel, or it may be any other third-party reporting tool. So the different components that you can use in a data warehouse solution on Azure looks like this. So again, I just want to give you an overview. Don't want to delve into this too much because we will have a special dedicated webinar session just on analytics and big data and Azure, data warehousing on Azure. So to load the data, you can use the Azure Data Factory and get data from multiple sources, whether it's log files, media, unstructured, business and custom data, or whatever. You can also use the Azure Import Service and different APIs, GLA, and different tools, or you can get the data offline using Azure Data Box. You can also load the data directly into Cosmos DB if the source is a NoSQL database, or SQL database if the source is a relational data. The whole point here is that then you have to ingest the storage so you can use Data Lake Store or Azure Storage. And then the data processing side, you can use HD Insight or Data Lake Analytics, or you can create your own scripts using Spark ML, and then run it across Azure Databricks, and then store it on serving storage, which can also be Cosmos DB, Azure SQL Data Warehouse, or Azure Analytics Service. So Azure SQL Data Warehouse is essentially the single data warehouse for all of the data that you're getting from your log files, from your unstructured and your structured databases, and it's ingested and then it's processed and cleaned up essentially by Azure Databricks, for example, and then stored in your Azure SQL data warehouse, which then becomes your single source of data for your applications and for your dashboards in Power BI or Excel. Advanced analytics requires data acquisition and understanding. So you acquire data from multiple sources, and then you understand the data, and then The difference between this and data warehousing is that you now have a machine learning model. That's the modeling phase, where you need to train and validate this model to come up with different scenarios. And once you're happy with or you're satisfied with the results of the training of one specific machine learning scenario, say for example you're predicting or doing forecasting of inventory using certain types of standard algorithms. Um, you train the algorithm based on the data set that you have just acquired, and then after that you deploy the model so that it can be used by future applications. So the model creation deployment process, canonical functions from left to right, as you can see here from the screen. You collect the data, you then prepare the data, you train the model with the data that you have just gathered, and then apply the model against the data so that you can evaluate the model whether the results is accurate or not, and then deploy the model in various ways. So this is kind of how advanced analytics patterns work across Azure. So starting from left to right, so assuming that you have unstructured data from sensors and IoT devices, you may also have unstructured data from different log files and media, and you may also have structured data from different LOB applications and so on. So you can, of course, definitely use Azure Data Factory to orchestrate the data, getting data from these multiple sources using standard SQL Server scripts all the way to SSIS integration scripts that you have created using SQL Server, for instance. You then store the data on multiple options. You can put it on Azure Data Lake Store to account for unstructured databases as well, Azure Storage, Azure Cosmos DB for NoSQL data, and for structured data, SQL Server Database. Now, when you train the model, you have multiple choices, and this is where your data scientist will come in to determine which one can be used. First, the more simpler ones is you can use the Azure Machine Learning Studio to visually, using a GUI-based interface, create a machine learning model using algorithms in a drag and drop GUI interface. And then once you've already created that, you can either run it as an ML, as a machine on the Azure Machine Learning Service, or run it as ML server if it's a script that you've just created purely using R or Python. To run the models at scale, you can run it on Azure Databricks, or your machine learning model. You can also put it on top of the SQL Server itself, because SQL Server supports machine learning on R and Python to live together with the database on the same instance. You can also configure a data science virtual machine that's dedicated for just running machine learning algorithms, and then you process the data again using Azure Databricks and Azure HD Insight or Data Lake Analytics. As you can see, there's a two-sided arrow here because the data that you got here, you sometimes have to pre-process it first, take away duplications, aggregations, and so on. So you can definitely use any of these three tools before you subject it to the model. Now, once the model has already been trained, you can deploy it as a container managed by the Azure Container Service, so you can scale it, or you can run it on top of Azure SQL Database, again, as the in-database machine learning. Now, all the process data can then be stored again on Cosmos DB, SQL Data Warehouse, or Azure Analytics Service, which can then in turn become the source of data for Power BI dashboards, which will show you now not just the reported past data, but maybe predicted, forecasted data, because you already now have a model that's trained to do forecasting, or maybe embedded within applications that will do the forecasting for you. So here's another way of looking at the different advanced analytics patterns in Azure. For ingesting, you can use Azure HD Insight or Azure Data Factory, store it on Azure Blob Storage. The preparation and training of the of the um, of the machine learning model, if you will, is done within Azure Databricks. What I don't have here and what I haven't shown is that Azure Databricks supports multiple types of scenarios where you can prep and train, and you can prep the data and then train the model in a notebook, Jupyter notebook type of environment. And then you serve the model on Azure Cosmos DB and then serving it across intelligent apps using Azure Cosmos DB as the backend. And then serving the actual data Azure SQL Data Warehouse as an alternative and then showing it up on Power BI. All right, so I've just given you an overview of the data service. So we've covered quite a lot. Azure SQL Database. We've covered the Azure Managed Database for MySQL, Postgre, and MariaDB. We also covered Azure SQL Data Warehouse. We've covered the Azure Data Factory, and I showed you some high-level scenarios of how these components are used in data warehousing and big data analytics solutions, scenarios. But again, don't worry if you find the big data and the data warehouse scenarios quite basic. We'll have another webinar just to talk about those two scenarios. All right, just a few more reminders before I end this webinar. You can still get your Azure free account. You can go to azure.com/free and get your free account. You will get $200 of credit, 12 months of access to popular free services, and 25 or more services that are always free. The services that you will get include the following. So you got virtual machines, SQL databases, the bandwidth, disks, Cosmos DB, and blob storage. Some of the typical components that you will need to get yourself up and running for simple applications or even web-based or e-commerce applications, just to get your feet wet on how to use and deploy these components on Azure. So these are the limits. So once you go over these limits, for example, per month, that's the only time where your $200 credit becomes charged. Once your $200 credit becomes low or become close to near zero, you will get a friendly email and constant reminders in your Azure portal to say that your limit, that your $200 credit is almost exhausted. So you're therefore be given options to either continue that as a paid service via your credit card or get contacted by a partner so that you can continue your subscription. These are the different services that will always be provided for you for free across the 12 months while your Azure free account is still active. So you can see here things such as Machine Learning Studio, Log Analytics, Batch Compute, Search, Data Factory, which we talked about a while ago. So you can actually build a complete application or migrate a complete application using the Azure free service, the Azure free account for across 12 months so that you can get training. Speaking of which, you can go to Microsoft Learn. So this is the URL. Either go to docs.microsoft.com/learn/Azure or just go learn.microsoft.com. We already have training that has been pre-selected for you depending on the role that you have. So if you're an administrator, AI engineer, business analyst, business user, and engineer, scientist, developer, whatever, choose any of these roles and the content will be pre-selected and curated for you. You of course have to log in to make sure that you go back to the same content and so to keep track of your progress. You will get a badge at the end of the course that you can show your friends and your colleagues and put it on LinkedIn that you've finished the course. Some of the courses here actually have labs as well, which may need your free account, or some scenarios actually doesn't need your Azure free account. So you can still work on getting yourself trained. All you need is an internet connection and a PC and device that will with audio, hopefully. Because because most of the training here is not just reading, it's also on. We have a special school just for AI. So we have aischool.microsoft.com so users or customers can learn how to build AI machine learning capabilities, embed AI within applications, giving them, for example, the capability to see vision APIs, etc., and also embed chat capabilities within your applications as well using our conversational AI platform. Academy, Microsoft Academy, Microsoft Professional Program is still available. Once you visit this site, you will get a big banner that says it will no longer be available soon. But if you log in and you enroll in this, even though the program is no longer be offered, it will still be made available to you because you're already enrolled. So if, for example, you wanted to delve into the field of artificial intelligence, or let's say you want to become a data scientist, but you don't know exactly what a data science is, then select data science here, because it doesn't only it won't show you all the Microsoft tools that is typically used by data scientists, but it will even give you the basics of what data science really is all about. And some of the lecturers in this channel are actually professional lecturers from both the academe and the professionals. Complete documentation is available on Microsoft Docs. Just go to docs.microsoft.com and then select Azure here. And then all the documentation, code samples, links to GitHub where you can get the latest code samples. Code samples, you can see it here. Examples from our different customers and our different developers are also there. And then the documentation is always and constantly being updated in docs.microsoft.com. Now, if you do not want, or you want to supplement your learning through our learning partners, we do have a few of them that I'd like to mention. So CloudSwift is a partner of ours. They're our local partner that provides um, self-paced course learning material together with hands-on practice labs, some of which cannot be found on Microsoft Learns. And you can also get a Revalida to prepare yourself for the actual certification exams that you will take, so that you can get an actual Microsoft professional certificate or professional credentials for Azure Data Engineering, AI Engineer, and even Microsoft 365 or Dynamics. So mention the promo code that you see here in the bottom if you decide to make an inquiry on CloudSwift. DDLS is also one of our local training partners that provides Azure training from Microsoft Azure fundamentals to tracks to become a solution architect on Azure, administrator, and also a developer. So again, tell them that you tell them if you make an inquiry to get a discount, get this promo code, mention it to them that you have learned about this in one of the Microsoft Philippine webs. MISnet is also one of our learning partners that provides training, classroom training for Azure fundamentals, for architects, for administrators, for security, and different types of Azure services. You can see their prices over here. And if you want to take advantage of this bundle, training, exam retake, and also a practice test, you got the contacts detail here at the bottom. And finally, NTT Data is also yet another local training partner that can help supplement your training for on Azure and help prepare you for certification. So they have different courses on Azure development, becoming an Azure Solution Architect, Security Engineer, and also DevOps. So if you want to get a discount from these guys, mention the promo code, and then when you make an inquiry, and tell them that you've got the promo code from this website as well. Hey, so we are at the end of this webinar. So if you want to register for future webinars, you can see the URL here at the bottom. Just visit that URL and register on the future webinars. And you can see here in front of you, we have all of these scheduled until the end of December, with a few of them still with no fixed dates yet. But hopefully, I get to see you on these webinars. So that's it. This is the end of the webinar today on Azure Data Services. I hope that you've learned something new today, at least an overview of the different data services that you can choose. It's not all about virtual machines, folks. So the cloud is not all about getting a Windows Server or Linux virtual machine and then putting all of the required software that you would typically need to run your application on that VM. So there are a myriad and there are a number of options of managed services, some of which are that allows you to do analytics, data warehouse, operational databases, both on the open source side and on the Microsoft SQL Server side and NoSQL side that's fully managed by Microsoft, so you don't have to worry about the infrastructure and maintaining that infrastructure as typical as you would have to worry about if you run these yourself, or even if you run this on a VM or set of VMs. So thank you very much. And once again, thank you for spending the hour with us. We hope to see you in our future events and our future webinars. Sign up soon. And that's it. Thank you very much and have a great day. Bye.